Here we have an interesting question from IOQM based on number theory. A number n in base 10 is 503 in base b and 305 in base b plus 2. What is the product of the digits of n? So the actual number is n. So n is represented in base b. In base b, n will be, using the concept of bases here, it's going to be 5b squared plus 0b plus 3b raised to power 0. Now, how the bases actually work in number theory is that our normal numbers are in base 10. So suppose we have a normal number, like let us say 607. This can be broken down into 6 into the base raised to power 2 and plus 0 into 10 raised to power 1 plus 7 into 10 raised to power 0. So this gives us 600. This just becomes 0, and this becomes 7 into 1, since 10 raised to power 0 is 1. So this gives us 607. That's how basis works. Our normal base is base 10, but numbers can be represented in other bases, so we have to break them down in the expanded form first. How the exponent works? Well, the position of the digit, like this is the first, second, third digit. The position, we can take it as n, so the exponent will always be n minus 1 for the digit that it's multiplying with. So 6 was at the third position, so the exponent that its base got was 2, which was 3 minus 1 basically. Same logic applies here. 5 in the 503 in base b, 5 was at third place, so it got exponent 2 with its base. This got 1 and this got 0. So now we can solve in base b the value of n for base b. This will be 0 again, and this will be 3, since b raised to power 0 is 1. Now, the second piece of information given in the question is that number n is 305 in base b plus 2. So we're gonna write that now. In base b plus 2, we're going to do the same thing that I just explained about bases, just that we're going to replace this b with this entire b plus 2, and we're going to give exponent to this whole term, not only b or only 2. That's something to be careful of. So we're going to write it as not 5, it's 305. Therefore we're going to multiply b plus 2 whole square plus 0 into b plus 2, although this is going to be 0, plus 5 into b plus 2 raised to power 0. Now, this will become an expanded term of a plus b whole square, which will be b squared plus 4 plus 4b. This will be 0, so we can ignore that, and this simply will be 5. Now we'll solve this completely, which gives us 3b squared plus 12 plus 12b plus 5, further simplified into 3b squared plus 12b plus 17. Now we have two equations for the value of n in two different bases. But since we've simplified them, we can simply equate them. So equating 1 and 2, we'll get the value of b from here. We can put 1 on the left hand side, 5b squared plus 3, and 2 on the right hand side, 3b squared plus 12b plus 17. Now quickly solving this will go here, this will become 2b squared. This will simply become completely negative, so this will be 12b, and this will subtract with plus 3, so this will become minus 14 equals to 0. As you can see, we have a quadratic equation here, but first we can simplify it even further by dividing the whole thing by 2, it doesn't really matter. It just makes things easier for us. So it's going to be b squared minus 6b minus 7 equals to 0. Now we can solve this in two ways, either using the quadratic formula, or we can split the middle term and factorize this thing. Factorizing would be much more simpler here, since we can clearly see the factors over here. Splitting the middle term, since it's really close to 7, 6 can be just made into 7. And once we do that, we can further just get the value of b really quick here. We'll get 2 roots of the equation, this and this. Now bases are always positive, so we will reject this value for a question and only consider the positive root of the equation. Now when we're going to put this value of b in either of these equations, preferably the first one since it's much more simpler, we'll get the value of n as it is in base 10. So now we are going to solve 1 for b equals to 7, which will now become 5 into 7 square plus 3, and this will be 5 into 49, which is 245, plus 3 equals to 248. This is the value of n, but the question does not end here. The question asked us for the product of the digits of n. Therefore, we're going to now multiply these digits. So the product of digits of n is 2 into 4 into 8. This just becomes 8, and 8 into 8 is 64. So now we have our answer to this question in about number theory in basis, and the answer is 64.